We're looking at statistical inference on the mean or average of a group of data. We've been working on a problem to find a 95% confidence interval. We noted it was best guess plus or minus some number of standard deviations. And since we're analyzing a mean, the standard deviation is sigma over the square root of n, where sigma represents the standard deviation of individual observations in the entire population. And the question we were left with was, how much additional uncertainty do we introduce into the problem? Because we don't know that true population standard deviation. We've just got an estimate of it based upon our sample data. That was a historically important question in the development of statistical methods, and the answer was discovered by a gentleman by the name of William Seeley Gossett. And William Seeley Gossett had a job that many of you would kill for. William Seeley Gossett was quality control director for Guinness Brewery. True story. Every time I tell this story, the number of statistics majors surges. As quality control director, he is charged with ensuring the high quality of the product, and that involves some sampling. And there are limits as to how large of a sample one can take. I know many of you are committed to trying to expand the boundaries of those limits. Nevertheless, there are limits. Basically, Gossett found himself in a situation where he has restricted to relatively small samples. And this was novel because at the time, most statistical procedures assumed that you had hundreds, if not thousands, of data points. So he works out the mathematics for small sample issues and goes to publish it in the top statistics journal of the day because it's an important finding. And the fine people of Guinness did not want the fine name of their company sullied by association with anything so disreputable as a statistics journal. And so Gossett was required to publish under a pseudonym. And the pseudonym, the pen name he chose, was Student. And to this day, his result is known as Student's T distribution. What is his finding? Well, let's draw a picture. Always draw a picture. The blue line represents our old friend, the normal distribution. What Student found was that in this situation of having to estimate a standard deviation, the effect was that there was still a bell curve of possibilities, but it's a bell curve that was more scattered out. There was a bigger chance of making a big mistake and less of a chance of being right on target. And just like the normal distribution, so too we can find values associated with Student's T either from tables or from Excel functions. And I'll focus on use of Excel functions in this class. But again, if you're familiar with the tables from elsewhere, that's fine with me. There are two sets of functions in Excel. There's a set of dist functions for when we have the cutoff score and are looking for a probability associated with it. And also a set of inverse or INV functions for when we know the probability and are looking for the cutoff score associated with it. And all of them involved DF, degrees of freedom. And later on this term, we'll go into more detail as to what these degrees of freedom are. For now, let's keep it simple. Degrees of freedom is simply sample size minus 1. Have we seen n minus 1 before in this or a previous life? Yeah, when we find a standard deviation, we divide by n minus 1, remember? It's the same n minus 1. And so in sum, we've already noted in previous modules that if we're analyzing proportions, we've got a z-score and an expression for the standard deviation, the uncertainty associated with that sample proportion of root p1 minus p over n. What we're noting here is that if we're analyzing means, we do it exactly the same, only a little bit different. It's now going to be a t-score rather than a z-score. And the standard deviation will now be sigma over the square root of n. But other than that, confidence intervals and hypotheses tests work in the same way. And in the next video, we'll finish off working through our example problem.